Now we are studying about the Young's modulus of a stretched string. First, we have to know that what is the Young's modulus. We have studied that Young's modulus is equal to stress by strain. So the longitudinal stress by the longitudinal strain. This is the definition for your Young's modulus. Now, by using this, we have to define in the stretched string. Now, let us consider a diagram. Now, we are considering a rigid support to a length L, and for this length L, we are attaching the mass M. Now, when we are applying the mass M to your support or to the length, there will be a change in the length, that is your dl. Okay, when we are applying the mass to the spring or to the wire, there will be a increase in the length. Okay, that we have taken as the dl. And let us consider small m is the mass, l means length, original length, and dl is the change in the length. dl is the change in length. Now, according to this, we have to find here y is equal to, we are considering longitudinal stress. We know that definition, force per unit area. Whole divided by longitudinal strain is there. Again, we are considering change in the length to its original length. Now, dl by l we are considering. Or this can be written in the form of y is equal to f by a into l by dl. We are getting the equation as y is equal to fl whole divided by a into dl. Now we know that cylindrical wire, the area of a cylindrical wire, a is equal to, we are considering pi r square. The area of a cylindrical wire, a is equal to pi r square. Next we are substituting y is equal to f into l divided by pi r square into dl. Therefore, y is equal to, we are getting the equation force into length divided by pi r square into dl. This is the Young's modulus for a stretched string. When we are applying any spring or when we have taken here wire, if the original length L is there, when we are applying the mass, there will be change in the length. By using this, we are getting the equation as y is equal to f into L divided by pi r square into dl. R is the radius, dl is the change in the length, L is the original length, f is the force. Next, we are studying about the stress strain curve. Now, according to this, first we have to know the curve. It is the graphical representation of the stress and the strain is called as the stress strain curve. It is the graphical representation of the stress and the strain is called as the stress strain curve. Now, let us consider on the x-axis we have taken the strain, on the y-axis we are considering the stress. Now, here we have given the name. Let us consider one is your OB and another one is your OA. Now see here. Now first from O to A, what will happen? We have to study here. Now according to the OA, when stress is 0, strain is also a 0. Now at a starting point, stress and strain is always 0. Starting point, the stress and strain is always 0. Now next we are considering at the point of A. When the stress increases, strain also increases up to a point capital A. When the stress increases, strain also increases up to the point of the A. This point A is called as the proportional limit. This A we are calling as the proportional limit for the point of the A. Next, we can tell that from O to A or from OA, there it obeys the Hooke's law. It obeys the Hooke's law. Now, according to the definition of the Hooke's law, we can tell that it is directly, stress and strain is directly proportional by using your Hooke's law. Now, next we are considering the point from A to B. Now, let us consider from the point A to B, there will be the increase up to the point and this AB strain is permanent to the BC. But BC does not obey the Hooke's law. Here it does not obey any Hooke's law. It does not obey Hooke's law. It does not obey the Hooke's law. Now according to this, again the wire C is elongated if the longitudinal stress is not applied. Next, last one we are telling that after C goes on decreasing at the some point, that time we are telling that the wire breaks at the point of the D. The wire starts to break at the point of the D. When it is breaking at the point of the D, this D we are calling as the breaking point of the wire. This is just about your stress strain curve. Stress strain curve means what? It is the graphical representation of the stress versus strain. Now just we can consider when stress is 0, strain is also 0. Second point, we can tell that stress is increases, strain is also increases. And the point A we calling as a proportional limit. Now next, here's last point D, we are calling it as what? Breaking point of the wire. These are the some important conditions we have to study in your stress, strain and curve. Now from this we have completed your chapter 9. Next we are studying about the important questions on the chapter 9. Now first they will ask define stress. Next define strain. Next types of the stress. Next one, types of the strain. Define Hooke's law. Next, define Young's modulus. Young's modulus. Bulk modulus. Definition of your bulk modulus. Shear modulus. Next, define elastic moduli. Next, here we have to study or we have to give the explanation for your Young's modulus. Explanation of the Young's modulus in a stretched wire. In a stretched wire. Next, define stress strain curve. Give the explanation for the stress strain curve. Of stress strain curve. Next one we have to study types of stress. We have to study what is the longitudinal stress. Longitudinal stress and longitudinal strain. And longitudinal strain. In the same way again we have to study what is varying stress and varying strain. Next last question, what is tangential stress and tangential strain? These are the questions which they can ask in your exam on the chapter 9. Next one, what is lateral strain? Next we are considering what is Poisson's ratio. Last one, define the modulus of elasticity.